Let's delve into the fascinating world of Neanderthals, uncovering not just their survival skills and tool-making abilities, but also their intriguing sexual lives. These ancient humans, who roamed the earth alongside early Homo sapiens, exhibited unique behaviors that challenge our perceptions of prehistoric relationships. From evidence of complex mating rituals to potential same-sex interactions, Neanderthal sexuality was likely as varied and nuanced as our own. Neanderthal mating habits were significantly influenced by environmental factors, which shaped their reproductive strategies and seasonal variations. As these ancient humans adapted to the harsh climates of Europe and Asia, their mating patterns likely fluctuated with the availability of resources and the demands of survival. During warmer months, when food was abundant, Neanderthals may have engaged in more frequent mating, fostering a sense of community and strengthening familial bonds. Interestingly, evidence suggests that Neanderthals may have practiced mating with multiple partners, creating complex familial relationships that enhance genetic diversity and social cohesion within their groups. This behavior could have been a strategic response to the challenges of their environment, ensuring the survival of their lineage. Additionally, the digit ratio theory, which examines the lengths of fingers as indicators of prenatal hormone exposure, offers insights into competition for mates among Neanderthals. A lower digit ratio has been associated with higher levels of testosterone, potentially influencing mating success. By understanding these dynamics, we gain a deeper appreciation for the social structures and reproductive strategies of Neanderthals, revealing how their mating habits were intricately linked to their environment and survival. This exploration highlights the complexity of their relationships and the evolutionary implications for modern humans. When examining the anatomical differences in Neanderthal reproductive organs, one notable feature is the absence of spines on their penises, a characteristic found in many other primates. This absence suggests a distinct approach to mating behaviors, as penile spines are often associated with competition among males for female attention. Without these spines, Neanderthals may have relied more on social bonding and emotional connections during mating, potentially fostering deeper relationships within their groups. This anatomical trait could imply that Neanderthal mating strategies were less about aggressive competition and more focused on cooperation and familial ties. Furthermore, the evolutionary advantages of these reproductive strategies are significant. By prioritizing social bonds and emotional connections, Neanderthals may have enhanced their chances of successful reproduction and child rearing, ensuring the survival of their offspring in a challenging environment. This approach could have led to stronger family units, which would be beneficial for nurturing young Neanderthals in the harsh climates they inhabited. Overall, the unique anatomical features of Neanderthal reproductive organs not only reflect their mating behaviors, but also highlight the evolutionary adaptations that contributed to their success as a species, offering valuable insights into the complexities of human evolution. Interbreeding between Neanderthals and early humans presented several risks that could have significant consequences for Neanderthals. One potential outcome of such mating was the introduction of genetic anomalies, which could arise from the mixing of distinct gene pools. These anomalies might have led to health issues or reduced fitness in Neanderthal offspring, posing challenges for their survival. Additionally, the offspring of Neanderthals and early humans faced unique survival challenges, as they had to navigate the complexities of belonging to two different ancestral lineages. This dual heritage may have resulted in difficulties in social integration, impacting their ability to thrive within either group. Environmental changes further exacerbated these challenges, as fluctuating climates and shifting ecosystems placed immense pressure on Neanderthal populations. As resources became scarce, competition for food intensified, making it increasingly difficult for both Neanderthals and their hybrid offspring to survive. The combination of genetic risks from interbreeding and the harsh realities of their environment likely contributed to the decline of Neanderthal populations. Understanding these dynamics provides valuable insights into the complexities of human evolution and the factors that influence the eventual fate of Neanderthals in the face of changing circumstances. Hemolytic disease of the fetus and newborn ADFN is a condition that arises when there is an incompatibility between the blood types of a mother and her fetus, leading to the destruction of red blood cells in the newborn. While specific data on ADFN in Neanderthals is limited, it is believed that this condition could have been present in both Neanderthal and early human populations, particularly as interbreeding occurred. The mixing of distinct blood types during these interactions likely contributed to the spread of ADFN, as incompatible blood group antigens could have emerged in their hybrid offspring. This genetic incompatibility would have posed significant challenges for the survival of these newborns, potentially leading to increased mortality rates. The implications for Neanderthal reproductive success were profound. If ADFN affected a substantial number of their offspring, it could have hindered population growth and contributed to their decline. As Neanderthals faced environmental pressures and competition from early humans, the added burden of ADFN may have further compromised their ability to sustain healthy populations. Understanding the impact of this disease highlights the complexities of Neanderthal survival and the potential genetic challenges they encountered in their interactions with early humans. Investigating the evidence of inbreeding among Neanderthals reveals intriguing patterns that have emerged from various archaeological sites. Genetic studies of Neanderthal remains, particularly those from sites like the El Sidar and cave in Spain and the Denisova cave in Siberia, indicate that inbreeding was a common practice. Analysis of mitochondrial DNA has shown that some Neanderthals shared a high degree of genetic similarity, suggesting limited mating choices within small, isolated groups. This inbreeding could have led to a range of genetic consequences, including increased susceptibility to diseases and reduced genetic diversity, which may have hindered their adaptability to changing environments. Furthermore, the social structures of Neanderthal groups likely played a significant role in shaping their relationships. Small, close-knit communities may have prioritized familial bonds, leading to a preference for mating within the group. This behavior, while reinforcing social cohesion, could have inadvertently increased the risks associated with inbreeding. As Neanderthals faced environmental challenges and competition from other hominins, the implications of their inbreeding practices became increasingly critical, influencing their overall survival and contributing to the eventual decline of their populations. Understanding these dynamics provides valuable insights into the complexities of Neanderthal social life and genetics. Neanderthal groups were typically smaller and more isolated, often consisting of close-knit family units. In contrast, early humans formed larger social groups that facilitated broader mating opportunities and genetic diversity. This difference in group size likely influenced mating practices, as Neanderthals may have relied more heavily on familial ties, leading to a preference for inbreeding within their limited social circles. Monogamous relationships, which became more prevalent in human societies, offered several advantages, including increased stability for raising offspring and the establishment of cooperative partnerships that enhanced survival. These relationships allowed for the pooling of resources and support, which was crucial in challenging environments. In contrast, the social dynamics of Neanderthal groups may have contributed to their population decline. With fewer mating options and a tendency toward inbreeding, Neanderthals faced genetic bottlenecks that reduced their adaptability and resilience. As environmental pressures mounted and competition with early humans intensified, the limitations imposed by their social structures likely hindered Neanderthal reproductive success, ultimately impacting their survival and leading to their eventual extinction. Understanding these dynamics provides valuable insights into the complexities of Neanderthal social life. Neanderthal sexual behaviors range of fascinating themes, much like their relationships. From their unique mating habits influenced by environmental factors to the implications of interbreeding with early humans, it's clear that Neanderthal sexuality was multifaceted and deeply intertwined with their survival strategies. We discussed how social structures shape their mating practices, often leading to inbreeding, and examined the potential consequences of these behaviors on their genetic diversity and reproductive success. Understanding Neanderthal relationships is crucial in the broader context of human evolution, as it sheds light on the social dynamics that have shaped our own species. I hope you found the details of this story as fascinating and unsettling as I did. You, mysterious, curious, intellectual, disturbed, beautiful people. My name is Penny Flick, with Kreep-ish. I look forward to sharing more of these stories that captivate and intrigue our minds, which can challenge our way of thinking. Comment on your thoughts below as I continue to uncover the mysteries of our history, true crime, paranormal, conspiracy, and cringe-worthy, creepy content. Until then, keep questioning, keep exploring, and remember that the truth is often stranger than fiction.